So as you can see, we're going to be jumping ahead now. We're going to jump ahead to chapter 10. This summer, your teachers from Thorntown as well as Granville Wells, we got together and we looked at all the different things that need to be taught before the February and then the April I-STEP test. And there are some things that we don't need until later on in the April I-STEP test. So we're jumping ahead to chapter 10. Now, one of the things you're going to notice is on this video, number one, this video is a little longer because there's a lot of different things that I need to go back over that you haven't talked about since maybe 4th or 5th grade, or maybe we've only mentioned once or twice this year. So we're getting into shapes and geometry and how to find area and things like that. But you'll also see at the very end, there's going to be some extra questions, and I am going to pass out a piece of paper to you that you can work on those extra questions. It seems so far out of setting up for the first 3 lessons, there's about 3 on each of the review sections on the homework that we aren't going to be able to teach before we actually get to it. So I'm going to introduce briefly ways to solve problems that are similar to what you're going to have on homework, and I'm just going to ask that you follow along and practice on those so you can learn those key concepts so homework is understandable. I'm going to caution, I know there are several of you who are picking up the bad habit of watching this and fast forward. You're not going to get everything that I say. You're not going to get a complete comprehension of everything I'm asking you to do, and you're going to be rushing through. This is not how fast can I get it done. If it takes 20 minutes to teach a lesson, if it takes me 45 minutes to teach a lesson, all of those minutes are important pieces of information for your understanding of mathematics. And that's what our goal is this year. Not to be an A student, not to get a pass plus on I-STEP test, is so that I understand math so when I go into 7th grade, I can be successful as a 7th grader and moving forward. So we're talking about area. Today's lesson is area parallelograms. And a parallelogram means that the opposite sides are parallel one to another. So when I look at a rectangle, I know the top and bottom are parallel. They don't intersect. They go straight across from one another. Same with the sides. A square, top and bottom is parallel, sides are parallel. This is called a parallelogram, even though they're all parallelograms, because it's tilted. So we have sides that are parallel, top and bottom are parallel. The difference is that squares and rectangles have right angles, where a parallelogram like a rhombus is going to have slanted angles. Some are going to be obtuse and some are going to be acute. We have to make sure that we find a perpendicular height. And what a perpendicular height means is it's going to have a right angle. And these are your right angles where they equal 90 degrees. It's a quick review of some of the things you've learned in previous years. But all of these shapes and all of these formulas are things that we're going to be going over in lesson 10, but also moving forward throughout the year. Because these things we know are on the I-STEP test. And we know you can be successful with them if we just make sure that we teach them and we practice them and we use them over and over and over again. So today's lesson is just going to focus over here on those parallelograms. So let's look at what the first introduction tells us for chapter 10, lesson 1. It says the area of a figure is the measure of the number of unit squares needed. So once again, we can do the metric system. We can have centimeters and millimeters and meters and kilometers. We can do our standard unit of measurement, which we talk about with inches and feet and yards and miles. So we know that we're just going to talk about an area that has a parallelogram shape, rectangle, square, rhombus, trapezoid, so on and so forth. And we're going to figure out how much space is inside of it. That's all area is asking. How much space is inside of there? So when we talk about length, this goes back to 3rd grade. You learned length in 3rd grade. That's talking about the long one, or usually it's also talking about the one that's on the bottom. So our length, when we look at this one, is 4 units. We don't know what it's measuring. It could be measuring in inches. It could be measuring in miles. When we talk about the width, then we're talking about how wide it is, or here in this instance, we're talking about how tall it is. And in this one, we can see where it is 3 units. So when we find the area, then we talk about this formula. And this formula tells us that we have length times width. Now some of you get confused on the perimeter. So a quick review of perimeter before we do the calculations for area, they are 2 different things. Perimeter is adding, area is how much space is on the inside, so it's multiplication. On perimeter, I count how many are on the outside. What I've seen some of you do when it came to plotting squares and rectangles on your coordinate planes is you don't count correctly. You count up 1, 2, 3, and then you just try counting around. So you'd end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not the way we count perimeter. We count how many are up. There are 3. Over here would be 3. How many across? I have 4 across, and down here I'd have 4 across. So I have to count the edges of the shape is what we're counting, not just how many boxes make up going around. So when I talk about the edges then, I have the 4 and 4, the 3 and 3, and when I add those together, I get 14. When I look at my area then, I'm talking about using those same numbers, how many edges is on the width and how many edges is on the length, but I'm going to multiply because that tells me how many fill up the inside of my shape. So when I use this, it either shows me that length times width, or I just slashed it so you see it better, or LW, and L touching W, when they're touching each other, once again that means multiplication. So when I take my 3 times 4, then I know I'm going to have 12. Now I've added down here base and height, because if it's not just a regular shape, which means it has right angles, and it has the sides, so it would have to be a square or a rectangle, then we talk about base and height, because when I have a tilted shape like a rhombus, then I don't have those right angles, those 90-degree corners like this one is nicely drawn for us. So length and width is the same thing as base and height. When I take those measurements then and I take 3 times 4, then I get 12 units. So we're saying that the area, how much is inside of that rectangle, is 12 units. If I count them, then I would see that it is indeed going to be 12 different units that are inside. Now when I get into this idea, this introduction they give me, they're going to be talking about these pieces that she's going to be making a blanket out of. But what I want to focus in on is what we're talking about here, connecting us between area for length and width and area being base and height. So it says we're going to draw a parallelogram on grid paper and cut it out. Now we're not physically going to do that. We're just going to look at what we're doing. So we have the parallelogram. We see that the base of the parallelogram, or the length, if it was a regular quadrilateral, then it's 9. And the height, notice the right angle. The height is 4 centimeters. It says to cut it out of the paper and then cut along the dashed line to remove the triangle. So we're saying cutting up where this height is. So if I do that, then I would be taking and moving it down here to the end where it says to move the triangle to the right side of the figure to form a rectangle. So what they're saying is if I take a parallelogram, rhombus, where it's tilted here, and I cut off the triangle where it is tilted and go straight down to the base of the shape, and I just slide it over to the end, then I end up making a rectangle. And then my area of length times width works. Well, when I talk about length times width then I also have to look at the base and height. So if I take off that triangle and I move it to the end and I get a rectangle, then I would have basically the same formula. My length times my width then is also going to be the same thing as my base times my height. So sometimes, probably most of the time, you're going to hear me talking about the base and the height. And I know when I show my formulas, I use base and height, because base and height works for all quadrilaterals, but length and width doesn't work for parallelograms and things that have tilts to them without the right angles. So it's the same wording, or the same idea, it's just different wording. Either way, if I find my area of this rectangle, I know I have a length of 9, I know I have a width of 4, and when I multiply those together, I get 36 square centimeters. When we get into area, we also have to remember that our label is being multiplied, because I have 9 centimeters multiplied by 4 centimeters, And when I have centimeters times centimeters, that's where that squared comes in. Squared, once again, just is written with an exponent of 2 after the label, or you can actually write out the word square, or you can abbreviate it SQ, and then in that case it's cm, which would mean square centimeters also. But the idea of the base and height working, I have to locate where the right angle is, which they've drawn for you with that little box. That little box, if you remember from previous years, it means right angle or 90 degrees. So I'm still going to take my base of 9, I'm still going to take my height of 4, and I'm still going to get that it's 36 centimeters squared. The key to remember on all of these, and I believe I've showed you on each of the problems, is that you have to use where the right angle is. And in this case, sometimes the right angle is going to be on the inside, sometimes it's going to be on the outside, sometimes they'll indicate it because it's a square or a rectangle. But you have to use where the right angle is and those 2 line measurements that can make up your right angle. So when we talk about the base of a parallelogram, we're also talking about the length, L-E-N-G-T-H, length of your rectangle. Once again, please fill these in so you understand what it is that we're talking about. When I talk about the height of a parallelogram, well, then I'm also talking about the height or the width, W-I-D-T-H, width of a rectangle. The same wording is what the answer is. The area of a parallelogram is the same as the area of a rectangle. So for a parallelogram with a base and a height, then I know that I can use the formula of base times height, or B times H, and then whatever that label is, I square it. Now once again, on my label squared, I always show it with an exponent of 2 because I'm told that that's 2 of the label. You can write it out in complete words, square centimeters. It takes more time. If you abbreviate it to SQCM, that would also mean square centimeters. Or if you just put the cm with the exponent of 2, that means square centimeters. Once again, just as a mathematician, that's the way I'm generally going to write squared centimeters. So when I find this information, then I know that my using base times height, I get 36 square centimeters. So the area of the quilt that they're talking about is 36 square centimeters. On the next one then, notice the formula they give you is using base times height. And why is that? Because I have a parallelogram, it's tilted, it's not a regular rectangle or square where the 90-degree angle is. So they give you 2 lines. Now on this lesson, they don't try to trick you by adding a third measurement, but you're going to see quickly, and I know it'll be on your I-step test, they're going to give you 3 measurements. They're going to put a measurement here, or they're going to put a measurement here for the sides, the length of the sides of this parallelogram. And if it's asking you area and not perimeter, you only use where that right angle is. If I don't have a right angle, then I'm going to get myself in trouble. Now I want you to remember that B touching H just means multiplication. And so a quick review on multiplication, the way you can see multiplication in all of these ways. When you were younger, it was always written with the X for multiplication sign. But now we have them touching. We can have parentheses used where the first one's in parentheses and not the second, or the second one's in parentheses and not the first, or they're both in parentheses. All means multiplication because they're all values that are touching. Or we also have that floating dot. Once again, it's not a decimal point because it's not on the baseline. It's a floating dot, which means multiplication. So when I multiply then, I'm going to use my base, which they showed me as 6.3. I'm going to use my height of 2.1, and then I'm simply going to multiply them together. And when I multiply, I, once again, prefer to put my largest value on top, or the one that actually has the most digits on top. It makes it easier to do my math. I always start in my bottom right number, or my, what would be a ones, it was a whole number. In this case, it's my tenths number. But this bottom right corner is where I always start with multiplication. I multiply by 1, and I get 63. My second number always tells me to bring down a 0. Have to hold that place value. Then I multiply by my next number, and when I multiply by 2, I get 126. Adding those together then, I get 1323, but I have to remember I'm multiplying with decimals, right? So I have to count those decimal spaces. I'm not counting decimal points. Now in this situation, my decimal points is 2, but my decimal spaces is 2 as well. So that one wouldn't throw me off, but if I had an extra decimal space in there, if I only count decimal spaces, my answer is going to be wrong. So make sure you're counting decimal spaces. It's why I always underline them diagonally and show that I'm counting my decimal spaces. And then I always move it from right to left 2 times. That tells me that my answer is 13.23, 13 and 23 hundredths. 13 and 23 hundredths what? 13 and 23 hundredths square meters. Because once again, they gave me meters in my measurements, but I have to square it when it's area. My second example they give me then, it says a square is a special rectangle in which the length and the width are equal. So then they say, well, you know, we can talk about length times width. We can talk about side times side. We can talk about base times height. Here they give you s squared. Well, s squared just simply means that I'm going to multiply. So my exponents, once again, tells me that my base number is multiplied by itself however many times the exponent tells me. So whatever the s is equal to, I know that I'm going to multiply it by itself, so it'd be s times s. In this case, it's 9.5 or 9 5/10 squared. And 9.5 squared looks like 9.5 times 9.5. So I would set that up as my math problem. Once again, starting my bottom right and multiply. I get my 475. And then a second number tells me to bring down a 0. Once I've brought down that 0, I multiply with my second number of 9. Bringing down my 0 then, 9 times the 95 is going to give me 855. Adding those together, I get 9025 with 2 decimal spaces. So I count my decimal spaces and move it over from right to left 2 times. So I end up with 90.25 or 90 and 25 hundredths as my answer. And so therefore for my square, my area, I know, because it gave me measurements of centimeters, is 90 and 25 hundredths square centimeters. So area has to be squared when I'm doing these math problems. For example 3, it tells me a parallelogram. Now this one, they're going to try to trick me on, because I'm not given one of my measurements, am I? When I look at that parallelogram, they tell me my area, the space inside of it, is 98 square feet. My base is 14 feet, and my height is equal to a question mark. Well, if I just fill in the formula that I know my formula is area is equal to base times height, and so I take the numbers that they show me in my shape, and I add them in there. So I end up with 98 is equal to, because that's my area is 98. It's equal to my base of 14 times height. Well, I don't know how to do that, right? Well, they tell you, it says to use the division property of equality. So division property of equality, something I'm going to introduce to you now, should have been taught in 5th grade, but we're going to review it just in case you don't remember, or you don't really know what that means. Division property of equality means that I'm going to divide to get my letter by itself. Okay, so I need my x all by itself, whatever my letter is. So this is where we have algebra, and algebra once again is just math with the letters, which you've been doing since you were little. 2 plus 3 equals b. Well, what does b equal? Well, 2 plus 3 is 5, so b has to be equal to 5. Well, here we're using that concept, but we're going to do the math to figure out what x is equal to. Now, you may pop into your head and know what 4 times is to get 28, but mathematically we have to know how to do it, because we're going to start using mixed numbers, we're going to start using decimals, and that's not going to be math we can just do in our head. So the first thing I know with this division property of equality is that I have to get my letter by itself. So I always circle it so I can see what I'm working with, and then I look at what else I'm doing. Well, in this case, I'm multiplying by 4. So instead of using these big words of division property of equality, I say you're going to do the opposite function on the opposite side. Functions, we have 4 main functions: adding, subtracting, multiplying, and dividing. The opposite, so the first 2, adding and subtracting. If I'm adding, I'm now going to subtract. If I'm subtracting, I'm now going to add. My last 2, multiplying and dividing. If I'm multiplying, I'm now going to divide. If I am dividing, I'm now going to multiply. So on this one, I know I'm multiplying by 4. So to get rid of it, I'm going to do the opposite function on the opposite side. So the opposite function means on that current side, I'm going to divide. Since I'm multiplying by 4, I'm now going to divide by 4. Then when I do it on the opposite side, I show the same thing. I'm also going to divide on the opposite side. So I'm showing over here, I'm dividing by 4 and dividing by 4. And once I've divided by 4 on the left, what's that give me? 4 divided by 4 is 1. So now I'm left with x is equal to 28 divided by 4. And when I have 28 divided by 4, I know that x is equal to 7. So when I do the opposite function on the opposite side, then I know, because fractions are division, that I'm going to divide numerator by denominator. 28 goes inside the division box. Handy dandy calculator, 28, because it's inside the box, goes into my calculator. Divided by 4, I'm going to get 7. Knowing how to do that helps me move forward on this problem. So if I'm using that division property of equality, or doing the opposite function on the opposite side, which to me is much easier to say, then over here I have that 14 is multiplied by h. I have to get the height by itself, right? So I'm multiplying by 14, so I'm going to have to do the opposite function, divide by 14. On the opposite side, divide by 14. So I'm going to show that I'm dividing both sides by 14. And once I do that, then I know I can cancel those out, because 14 goes into 14 one time, just becomes 1. And I end up with that h is equal to 98 divided by 14, or 98 over 14. Top number goes inside my box. I divide by 14, 98 divided by 14, handy dandy calculator, 98 divided by 14 equals 7. So I know my height is equal to 7, and then notice the label on that. It's just feet, isn't it? I'm not finding it for area, where my area is my squared feet. I'm just finding the length of my height, or the length, or the measurement of my length. So my label is going to be a straightforward label of feet, inches, meters, yards, miles, whatever it is, if I'm solving just for one of the sides. So we're going to stop and we're going to explain. Some of you are missing a lot of points because you're not explaining, you're only showing me math work. And when I try to stress to you that on the I step you have to do writing, when it tells you to explain, you have to explain. You have to use words. So we're going to explain the difference between the height of a rectangle and the height of a parallelogram. So think back what I said you had to have in order to find the height of a shape. Have to have a right angle, right? And on our regular shapes, like rectangles and squares, I have that right angle. So I'm going to put the height of a rectangle will include a side because it forms a right angle. So it's going to be where the base and the side, or the height, is going to connect, making that right angle for you. The height of a rectangle will include a side because it forms a right angle. Please write that down. Pause the video if you need to before I go on to the next part. If you're ready, then it says to also talk about a parallelogram. Well, the height of a parallelogram will have a line drawn to make a right angle. So that's the difference. Once again, parallelogram leans. It's kind of like the rhombus I was talking about. So they're going to draw usually a dotted line to show you the height of that parallelogram. If you're not finished writing down that information, please pause the video. If not, we're going to move on. So now we're going to do the practice problems. We're going to do several of them, so please stay with me. Take the notes, write them down if you need extra paper so you have things to look back on. Because once again, you're going to be able to use your book to go back and look at on your test at the end of chapter 10. Several of you don't have things written down in chapter 5's test, which you're working on yesterday and today, and you're really struggling because you're not sure how to do these problems. It's in your book. So if we write them down and we get to use our notes on our test, it makes our test much easier. So we're going to find the area of this parallelogram. Look at what I'm given. I'm given my base. I'm given my height. I should know it's a height because it's showing me that I have my right angle. Where the right angle is where my measurements are going to be that I use. So to find the area, I'm going to use my base times my height, where that right angle is. I'm going to set them up in a multiplication problem. So I have 8.3 times 1.2. When I multiply those together, once again, the easiest way, handy dandy calculator, 8.3 times 1.2 equals, when I multiply those together, then I know I'm going to get an answer of 996. When I multiply by my first number, then I know I bring down my 0 for my second number and multiply, add those together, I still get the 996. Counting my decimal spaces then, have to move it from right to left 2 times. So I know my area for this parallelogram is 9 96/100ths square meters. I know it's square meters because this was meters and meters. Meters times meters, there's 2 of them, so I have to have it squared. You could write square meters out. You could abbreviate it SQM. That would be square meters also. 3 ways you can show your label. On number 2 then, when I look at number 2, I see where my right angle is. My right angle, once again, tells me what 2 measurements I'm going to use. So I'm going to use a 15. I'm going to use a 6. Once again, not in this lesson, but coming up quickly, you're going to have a measurement here, or you're going to have a measurement here. That's just there to confuse you. It may be there because they're going to also ask you how to do perimeter and area on the same shapes, but right now we're just doing area. So if there's that third number there, please ignore it. Go to the right angle, use those 2 measurements. My base of 15, my height of 6, I put them together in a multiplication problem. 15 times 6, handy dandy calculator, 15 times 6 equals, when I multiply those together I get 90. No decimal spaces, so I know it's a whole answer of 90. 90 what? 90 square feet, because it's area, square label. Now notice this crazy shape. I have all sorts of right angles. Well, I could do that on a rectangle also, because by definition a rectangle has 2 sets of parallel sides and all the angles are right angles. A square is the same thing. 2 sets of parallel sides and all the angles are right angles, therefore it's a square. The only difference between a rectangle and a square is all sides are equal. So when I look at that math problem, I look at wherever the angle is. Well, I'm given these 2 sides, so I circled that particular right angle. I know that all sides are the same, so it is a square. So it really doesn't matter which of the right angles you circle, because all of your sides are going to be the same. That could be your s squared, which just simply still means I'm going to multiply the 2 together. So 2.5 times 2.5 equals, and I get 125 with 2 decimal spaces, so I have to move my decimal space over 2 times. Excuse me, I said the answer was 125. It's not 625. So when I move it over 2 times, it's 6.25, also said as 6 and 25/100ths. My label is already there for me. Notice it is squared because area has to have a square label. Notice I say that on every single one of the answers. Now on this one now, we've done decimals, but now we've got fractions. Well, how do I do that? I do it exactly the same way. I just go back to Unit 1 when we talked about using fractions, and Unit 2 where we use fractions, as well as 3, 4, and 5. I know how to use my fractions. I look at where my right angle is. It tells me that's my base and that's my height. I set them up as a multiplication problem because base times height. How do I multiply fractions? Well, every time that we do these, I'm going to show you to cross reduce. It really does make your math easier. I know some of you don't like it. You want to multiply across and then reduce, please do. But those of you refusing to cross reduce, often forget to reduce in the end. You're missing points because your answer is not reduced and it can't be correct. When I cross reduce then, the 3's are the same, and I have 2 even numbers. So in my even numbers, I reduce by 2's. That changes my 2 into 1, my 4 into 2. Because 2 goes into 2 one time, 2 goes into 4 2 times. Since the 3's are the same, they just automatically cancel out and become 1's. Then when I multiply across, I end up with 1/2. So I know that the area for this shape is 1/2 of a square foot. Why is it square foot? Area has to have square labels. Number 5. Now in this one, once again, I'm missing a piece of information. I'm given my area here. They tell me what the answer is. It's 11 square yards. I know my base is 5.5 yards, but I don't know what my height is. So I'm going to have to set it up as area is equal to base times height and fill in the information that I'm given. If I know that base times height is equal to my area, and I know that's my area, and that's my base, then I have to fill in with the information that I have. My base is 5 1/2. My area is 11. Now when I look at that, you should be jumping into your head thinking, well, I can't multiply and divide mixed numbers. So I have to switch that, don't I? I have to change it into an improper fraction. And once again, that tells me that I start at the bottom and I multiply and add. So when I multiply, I get 2 times 5, which is 10. I add 1, which is 11. And then I keep my denominator. So that becomes 11 over 2, or 11 halves. So 11 halves times h is equal to my 11. Now I have a math problem that I can work. Going back to the idea that we have talked about before, doing the opposite function on the opposite side. Once again, the book calls that the division property of equality. And still the steps are going to be to do the opposite function on the opposite side. Well, here I'm multiplying by 11 halves. So how do I get rid of it? Well, we talked about how when I have multiplication and division, if I'm starting with multiplication, I'm going to divide. So I'm going to divide to get that h by itself by 11 halves. So I divide by 11 halves over here. I divide by 11 halves over here. But I can't divide fractions, can I? So I have to keep the first one. Division becomes multiplication. Flip that second fraction. Over here, what am I going to have to do with my 11? Hopefully you thought, you're going to have to put it over 1. So if I put 11 over 1, and then I keep my first one, division becomes multiplication, flip my second fraction. Then I'm going to get this math problem. 2 over 11 times 11 over 2 times the h is equal to 11 over 1 times 2 over 11. So now I got to look at what I can do mathematically. Well, this is the law of reciprocals, and a reciprocal once again is a fraction that's flipped. The law of reciprocals is any fraction multiplied by its reciprocal is equal to 1. If I multiplied those together, I'd get 22, and if I multiplied these together, I'd get 22, and 22 over 22 is just 1. If I cross-reduce them, then I can see that they all cancel out. The 11s all make 1s, my 2 all make 1, so I know I'm just going to be left with my h. Well, if I go to the right side then, and I reduce what I can reduce my 11s, and that leaves me with multiplying across. 1 times 2 is 2, 1 times 1 is 1 in my denominator, 2 over 1 is just 2. So I've proven, leaving my h by itself, that my height is equal to 2. But to what? So when I talk about what I'm using then, I'm getting 2 yards. Why is it just yards? Because once again I'm finding my height when they've already given me my area. My area has a squared label, has that exponent of 2. My measurements are single, so it's only going to have the straightforward unit, in this case, yards. Alright, so when I go to this one, same type of setup. I'm given my area of 32 square yards. I'm given my base of 4 yards. I'm not given my height. So when I look at where my angle is, my right angle, then I know I'm setting it up as base times height is equal to my area, and then I just fill in with the numbers they give me. I fill in that my base is 4. I fill in that my area is 32. And then I have to go through opposite function on the opposite side. I was multiplying by 4, so in order to get rid of 4, if I'm multiplying, I have to divide. So I divide by 4. Opposite side, dividing by 4. So I'm left with h equals 32 divided by 4. And when I take my top number, put it inside the box, divide by my denominator, numerator divided by denominator, 32 divided by 4 equals 8. I know that my answer is going to be 8 yards. What is 8 yards? My height, which I was finding, is a total of 8 yards. Number 7, locating my right angle tells me my measurements that I'm going to use. I have my base, I have my height, so this one's straightforward. I'm looking for my area. When I take my base of 9 and 1/10 and my height of 6 and 4/10, I stack them. I'm going to multiply by the 4. Then I'm going to multiply by the 6. It's going to tell me, when I bring down my 0, that it's equal to 5824. Once again, multiplication of decimals. I have to count decimal spaces and move from right to left 2 times. So when I move from right to left 2 times, then I know what I have is 58 and 2400 square meters. Once again, area labels have to be squared. On number 8 then, I look where my right angle is. I have my 2 measurements. So once again, it's straightforward. Base times height. I'm going to take my base of 21, multiply it by my height of 8. When I multiply those together, I get 168. That's a straightforward answer. It's not decimal, so I don't have anything to move. It's just going to be 168 square feet. Now these look a little different. Why do these look a little different? Where's my shape? Well, they're going to try to confuse you, but they're also going to see if you understand how the formula works. I don't need a shape drawn in order to figure out what the area is or what a missing side is. So if I have a square, and I have that I'm looking for my area, and I have that the side is equal to 15 feet, then I have all of the information that I need to solve for the area. It's a square, so that tells me my s squared, or my 15 squared, and 15 squared means 15 times 15. So when I multiply those together, 15 times 15 is going to give me 225. When I take that answer up and I put it up there, what do I have to remember? I have to remember my label. So I know I have 225 when we're talking about feet, so it has to be a label of square feet. Once again, I always show it with an exponent of 2 because that says square feet. You could put SQFT. Good luck trying to write square feet in that little space. Parallelogram. Now I'm given my area. I'm missing my base, but I have my height. Still the same formula. It's still going to be base times height is equal to my area. So I plug in the information that I have. I have my area and I have my height. So when I plug those in, I know I now have b times 8 is equal to 32. Then how am I going to solve for it? Well, I know I have to get my b by itself, and I'm multiplying by 8, so I'm going to do my opposite function on my opposite side. So getting b alone, I'm going to divide by 8. Instead of multiplying my opposite function, that tells me to divide, on the opposite side, tells me to do it 2 times. So I end up with b is equal to 32 divided by 8, and when 32 divided by 8 is typed in my calculator, 32 divided by 8 equals, I know it's 4. So when I come up here, I have to have my label, and my label is going to be what? In this case, it's just going to be meters, because it's a straightforward unit of measurement. On 11, a parallelogram. Now I know that I've got mixed numbers. Still the same formula. I have my area, I'm given my base, but I'm not given my height. Plug in the information that I have. I know my area is 51 and 1/4. I know my base is 8 and 1/5. Can I use those in a math problem where it's multiplying and dividing, can I? So now I've got to change both of them into improper fractions. So my 8 and 1/5, start at the bottom, multiply and add, is going to give me 40 plus 1, which is 41. Keep my denominator. So I end up with 41/5. 51 and 1/4, bigger math problem, still done the same way. Start at the bottom, multiply and add. So 4 times 51 plus 1 gives me 4 times 51 is 204, plus 1 is 205. I end up with 205. Keep my denominator 4. So now I look at the math problem that I now have to work with. I have 41/5 times h is equal to 205/4. Got to get h by itself. I'm multiplying by this fraction. I don't want to multiply. I need to do the opposite function, then on the opposite side. So I'm going to just drop that off. Now, so one of the things I want you to start seeing is, I don't actually have to show that I'm dividing by 41/5 over here and then changing it to 5/41 times the 41/5. If I'm doing the opposite function, it's going to cancel it out. It's always going to be 1. If it's division over here and I do the opposite function, it's going to cancel it out. If it's addition, I do the opposite function of subtraction, it's going to cancel it out. See the pattern? Whatever I'm doing, as long as I'm doing the opposite function, it cancels it out and it leaves my letter by itself. We're going to be doing a lot of these this year. So I don't want you to have to show extra work if it's not needed. So that gets canceled out because I did the opposite function on the opposite side. The opposite function was division. So on the opposite side, I'm going to divide by 41/5. That's what I have to show. Now I have to show a math problem that I can do, and it's not that, is it? I got to keep my first one. Division becomes multiplication. Flip my second fraction, so I write my reciprocal. And then I'm going to see if I can reduce. Well, 4 doesn't go into 5. Does 41 go into 205? Well, if I had my handy-dandy calculator, find out it does. 41 goes into 41 one time, and 41 goes to 205 5 times. Now my problem's pretty easy. I end up with 5 times 5, and in my denominator, 4 times 1, so I get a 25/4. And then once again, this simple division, numerator gets divided by denominator, 25 divided by 4, 4 goes into 25 6 times, and then how do I set up my fraction? Because it's going to be a mixed number as an answer. Well, once again, my remainder is my numerator, my divisor is my denominator. And so when I write them, I ended up with 6 1/4. 6 1/4 what? Going up here, well, it's a measurement of a side, so it's just a straightforward unit of inches. So I have 6 1/4 inches. On the last one on the parallelogram, still given the area, still given only one side, so I'm going to have to go through the same process. I have the same formula every single time. Base times height is equal to my area, and I fill in with the information that I'm given. I'm given my area of 121. I'm given my base of 11. I'm looking for my height. How do I go about it? I do the opposite function on the opposite side. So I'm going to divide by 11. That cancels that out. That'll make it a 1, which leaves me with 121 divided by 11. And if you know your multiplication of doubles, which you learned in 3rd grade, then I know that 11 times 11 gives me my 121. So I have a height of 11 millimeters, excuse me. This last one then is from a story problem type situation. The height of a parallelogram is 4 times the base. The base measures 3.5 feet. Find the area of the parallelogram. So if I look at 3.5 times 4, because it's 4 times the base, I have to end up with a improper fraction. So I'm going to take 3.5, start at the bottom, multiply and add. 3 times 2 is 6, plus 1 is 7. Keep my denominator, so now I have 7 halves times 4, or 7 halves times 4 over 1. Cross reduce when I can, so 2 goes into 2 once, 2 goes into 4 twice. I'm left with 7 times 2, 1 times 1. So I know I'm going to have 14 over 1, which is just 14. So I know my answer for my area is going to be 14 square feet. Or if you want to write it like I do with the exponent of 2, that works as well. So that's all of those questions for knowing how to do the front page and the top 2 on the back of that assignment. And as I said, I noticed there are a couple of questions that we haven't gotten to because we're skipping some chapters. So from this point forward, and yes, I know this is a long video, it's a lot of information to learn, but take your time to learn it, please. We're going to talk about inequalities. And inequalities sounds like any quality. And it's exactly what it means. Quality is just a number or a value. And it's saying that it can be any of them. And what inequalities look like is a letter with a greater than, less than sign. Now we'll talk about here in just a second that it can be a greater than or equal to, or less than or equal to also. But what we're saying is we don't know what this x is. However, we know it's got to be greater than -2. So let's go through 5 or 6 of them that it can be. It can be -1. It can be 0. It can be 1 or 2 or 3 or 4 or 5 or 6, on and on forever. What it cannot be is -3, because -3 is less than -2. So an inequality tells me there can be anything that makes this a true statement. So let's look at anything that is greater than -2. Let's talk about each of these. Can x be equal to -1? Yeah, x can be equal to -1, so I would circle that as a possible answer. Can x be equal to -3? It cannot, because -3 is less than -2, so that's not it. How about 0? Can x be equal to 0? Yes, that was one of them that I mentioned, wasn't it? So 0 is greater than -2, so I know that's a possible answer. How about -7? Can x be -7? No, that makes it a false statement, doesn't it? Because -7 is less than -2, so that cannot be true. Well, how about +2? Yeah, that would work, because 2 is definitely greater than -2. So an inequality just says any number that it can be to make this a true statement. Well, let's look at what these signs say. This is an inequality sign also. We've talked about greater than or less than for quite a while, but what about this line here? Okay, that kind of changes a little bit of what it says. This one says that it's where the number is, any number that is less than whatever this is. Well, the number sign is on this side, so this says any number that is greater than whatever this is. This line changes it a little bit. It still says it's any number less than, but it also says or equal to. So if we think about an equal line, it has 2 lines. This is just the bottom line of the equal sign underneath my comparison sign. So it means it could be equal to, or it's going to be less than. So then this one, because it has that second line of the equal sign, it says that it's any number that is greater than, or it could be equal to. So let's look at a couple situations. It says on Sunday, November the 19th, the highest temperature for the day was 33 degrees. Write an inequality that would represent any temperature that could have been reached that day. So let's look at what it talks about. The highest temperature was 33 degrees. And I'm writing an inequality, so I'm going to use a greater than, a less than, a greater than or equal to, or a less than or equal to. So I have one of those 4 options to use. And I know that it has to be any temperature that could have been reached that day. So when I look at it, I know it's 33 degrees. That was what? That was the highest temperature. So I know that any other temperature could be less than that, correct? But could it be equal to as well? It could, couldn't it? Because it was the highest temperature. We know it got there. So what I'm looking at is an less than or equal to symbol. So I know that 33 degrees is greater than any other temperature, or it's equal to any other temperature that day. So my inequality is 33 is greater than or equal to X, or any other temperature that happened that day. Last one that we're going to look at has nothing to do with inequalities. It goes back to our idea of ratios, but it's going to have us writing something that we haven't written before. So let's look at what it says. In diving, it takes a diver 4 seconds to jump from the 20-meter platform and hit the water. In 1 second, the diver travels 5 meters down. In second 2, the diver has traveled 10 meters down. By second 3, the diver has traveled 15 meters. And in the final second, the diver has traveled all 20 meters. Write an equation that gives the relationship between seconds and distance. Let seconds be X and distance be Y. Now that sounds like a really complicated scenario, but it's not. So let's look at what it's talking about so we truly have a good comprehension of what we're being asked to do. So we're talking about a 20-meter platform, right? Way up there. We have somebody that's diving off of it. Okay? So that information really isn't pertinent other than the 20. Then we have to look at what it's asking us to do. It's asking us to write an equation. And what's an equation? Well, an equation, once again, is just a math problem that has an equal sign. So I have a value over here that is equal to an answer. All right, we can do that. We know how to do that. Well, what's the information it tells us? It says, let the X be seconds and the Y be distance. Have we done that before? We have, haven't we? When we talked about ratios and we talked about rates, we've talked about plotting the X and the Y, and we talked about how the X was always at the bottom and the Y was always at the top. So we've talked about this scenario, and we made boxes to look at the measurements to plot at an angle going on quadrant 1. So let's look at the information that we have and see if we have a pattern. So we know that when we dive 1 second, we went down 5 meters. All right. So when I dive 2 seconds, I went down 10 meters. All right. 3 seconds, 15 meters. And then when I do the fourth one, I have 4 seconds and 20 meters. So when I look at my unit rate compared to my other rates, I check the math. I'm taking the 1 times 2 and then multiplying the top by 2. And so I'm multiplying by 3s and I'm multiplying by 4s. These are indeed equivalent rates. So if I know that's true, then I have to figure out what I'm looking for. So I'm going to be solving for Y. And what is Y always going to be equal to? I'm not looking for a number once again. And that's where some of you are going to struggle. I'm not looking for a number, I'm looking for an equation. I'm looking for a math problem. So what's the math problem? Well, the math problem is that every single time I do it, I'm going to take that 5. I'm going to take that original unit rate and multiply it by however many minutes, or seconds, I'm jumping. So I multiplied by 2, I multiplied by 3, I multiplied by 4. Every time. The distance of 5 multiplied by the seconds that I'm jumping. So my equation is that Y is always going to be equal to 5 times X. Am I asking you to solve for a problem? No. I just need the equation written out that would always help me. So what if it was a 100-meter platform? Number 1 would be terrifying. But number 2, I could still figure it out. I know that if it was a 100-meter platform, that I would be multiplying 5 times something to get 100. So I can still use that information in any kind of scenario where I'm given what my Y is equal to. So Here's my suggestion, and yes, I know it's a long video, it's almost an hour long. Trust me, my throat's feeling it, and I understand, and this slideshow took me 4.5 hours to create. So I've taken the time to do this for you. 5.5 hours just to teach you one lesson. Please take the time and go back to those last 3 problems that we just did, because there are things that we haven't looked at before in ways that we haven't looked at them. And if you go back and review them when you do your homework, then hopefully that'll make sense to you. Once again, these videos are available to you on my website. They're available to you on YouTube. They're available to you in the classroom on Canvas at any time. When you take your test, you go back and watch any portion that you would need to help you remember how to do these problems. I'm not going to make you, obviously, but I would strongly suggest that you do, so you truly understand what it is I was talking about in those problems, instead of just writing down the same things that I showed you. Okay, so going back to just today's idea then, we're finding the area of a parallelogram. Area of parallelogram is length times width, which you have used for the past couple of years when it comes to squares and rectangles, but it's the same idea as base times height. And every time I find them, I have to have a right angle in order to have my 2 measurements. And then finally, once I have my area, I'm always going to square my label. If you have any questions, please ask. Please take the time to watch this video, put forth the effort that I've asked. I know you can be successful.